This is 8-2, trigonometric ratios. Try the warm-up problems and hit play when you're ready to see the answers. Since number 3 has an x on the bottom, I set it up as a proportion to make things a lot easier. So I put the left side 0.8 over 1, and then I could cross multiply to solve. So you could technically do the same thing on this problem as well if you wanted to. You get x equals 0.94 times 8.5, which is 7.99. Okay, reminder that similar triangles have proportional side length ratios. We would write the similarity ratio. Well, we call these trigonometric ratios. You may have seen the buttons on your calculator that say sin, cos, tan, written like this. Oops. Sin, cos, tan. Well, that's sine, cosine, and tangent, which are the 3 words here that we're going to be talking about. If you look at a right triangle, we know where the hypotenuse is. It's across from the right angle. And if you're talking about a specific angle, now if I'm talking about angle A, for instance, the sine of A is the opposite leg over the hypotenuse. So the opposite leg from A is lowercase a, and the hypotenuse is C. So we would call that A over C. So if those had numbers, say little a was 3 and C was 5, then we would write that as 3 over 5. That would be our trigonometric ratio. If you had sine of B instead, well, sine is opposite over hypotenuse. So looking at angle B, opposite would be lowercase b over hypotenuse is C. So it's B over C. If you're talking about cosine of angle A, the capital letters are the angles, and the lowercase letters are the sides. Okay, so if we're talking about cosine of angle A, now it's adjacent over hypotenuse. Well, adjacent means the leg that's touching the angle. So that would be leg B in this case, over the hypotenuse C. We know that the leg can't be C because C is not a leg, it's a hypotenuse. If you do cosine B, and this next one, that would be adjacent over hypotenuse. So if you look at angle B here, the adjacent leg would be A over the hypotenuse C. Okay, now let's take a look at tangent. So tangent of A, tangent is opposite over adjacent. So if you look at angle A, the opposite over the adjacent, which would be B right here, so it'd be A over B. Let's look at tangent of angle B. Get rid of all this stuff here. Tangent of angle B is opposite over adjacent. So angle B, opposite B over adjacent A. So notice that tangent, oops, didn't mean to do that. Tangent is opposite over adjacent every time. Opposite over adjacent. Cosine is always going to be adjacent over hypotenuse. And sine is always going to be opposite over hypotenuse. So someone created this, we call it SOHCAHTOA, where sine means opposite over hypotenuse. Cosine, adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. So you need to know that the S stands for sine, C is for cosine, T is for tangent. You also need to know that O stands for opposite, H stands for hypotenuse, and A stands for adjacent in order to have SOHCAHTOA work for you. So if we want sine of J, sine is SO, S-O-H. So opposite over hypotenuse. So look at angle J. Opposite from J is 60, and the hypotenuse across from the 90-degree angle is 61. So 60 over 61. It says write each trig ratio as a fraction and as a decimal. So 60 divided by 61 gets me 0.98 if I round to the nearest hundredth. 0.98. Okay, now let's look at cosine of j. Cosine of j would be adjacent over hypotenuse. So adjacent to angle J would be 11, the leg that's touching the angle, 11 over the hypotenuse. The hypotenuse is across from the 90 degrees, so it's 61. And 11 divided by 61 is 0.18. And now let's do tangent of J. Let's get a different color here. Tangent of J. Tangent is opposite over adjacent, the TOA. Tangent's opposite over adjacent. So opposite would be 60 over the adjacent, which is the touching leg, that's 11. So 60 over 11, which is 5.45. I'm going to add in the about symbol on all of these since we rounded. So you can do the now you try and hit play when you're ready to see the answers. If you needed help getting started, I've just written out all of my ratios, opposite over hypotenuse or adjacent over hypotenuse, etc., based on the SOHCAHTOA. So there are my answers in both fraction and decimal rounded to the nearest hundredth. Notice that in example C, I did not put the about symbol because it was exactly 2.4. I didn't round that one. Finding trig ratios in special right triangles. So this is a special right triangle. We're talking either 30, 60, 90 or 45, 45, 90. I see some 30s here, so I know this is a 30, 60, 90. So across from the 30 is the x, or the short side. I'll do s. So across is s, and then across from 60 is s radical 3, and across the hypotenuse is going to be 2s. So if I'm going to write sine of 30, well, that would be opposite over hypotenuse, which is 2s. And so I get, when I simplify that, the s's cancel, and so I get 1 over 2, 1/2. And you can check that in your calculator. If you type sine of 30 in your calculator, sine 30, enter, you'll get 0.5, which is 1/2. Okay, if I do cosine 30, let me write sine 30 equals, so cosine of 30 now is equal to adjacent over hypotenuse. So that would be the adjacent to 30 is s radical 3 over the hypotenuse, which is 2s. So the s's cancel, and so I end up with radical 3 over 2, which I can have because the radical's not in the denominator. Okay, tangent of 30. Tangent of 30 is opposite over adjacent. S over S radical 3. The S's cancel and we get 1 over radical 3, which we can't have. So I need to multiply top and bottom by radical 3. I end up with radical 3 over, or 1 radical 3, doesn't matter, over 3. So you can try the next two. I'll pause the video, and when you're ready, hit play so you can see the answers. For the last one, I did L, L, and L radical 2. You could also do X, X, and X radical 2. So notice sine and cosine are the same for the 45, 45, 90. And tangent of 45 will be 1 because it's the legs over each other. And since they're the same measurement, like say that was 5 and 5, it would be 5 over 5, which is 1. For example 3, you're just simply typing this in your calculator, so you get about 0.79 when you round sine of 52. Type cosine 19 in, you should get about 0.95. And tangent of 65, check and make sure it's about 2.14. Now please let me know if you did not get that answer, because your calculator needs to be in degrees. You should have like a little DEG in your calculator. And if not, it might be in radians if you're getting a different answer. So please actually check that, or all of your answers on the future test would be incorrect. If I'm looking to find side BC is what they're asking me to do right now. So if I'm looking to find side BC, I'm noticing that they gave me this angle B. I'm looking for the adjacent, and they gave me the opposite. So which trig ratio in SOHCAHTOA has to do with O and A, and that would be the TOA part of it. So therefore I know I'm using tangent. So I'm going to do tangent of the angle. So this is the angle. This is determined by what they gave you, what was given, and SOHCAHTOA. Put in the angle is equal to the opposite over the adjacent. So I can fill in the opposite and adjacent. The opposite would be, let me see, 10.2 over the adjacent, which is x. So if we calculate in our calculator tangent of 15, I get 0.26 equals 10.2 over x. So I would put that over 1, give myself a proportion because that variable's on the bottom and that can be confusing. And now I'm going to cross multiply. And when I do that, I get 0.26x is equal to 10.2. So divide both sides by 0.26. And x is equal to 39.23. And it says round to the nearest hundredth. So that's right, 39.23 would be the length of BC. So I'm going to write BC is equal to 39.23. For this next one, again, I'm talking about SOHCAHTOA here. So I need to see what was given to me. They gave me an angle, and they gave me this side right here, and I'm looking for QR. So according to this angle, I was given the hypotenuse, based on it's the across from 90, and the opposite leg from 63 degrees. So I have opposite and hypotenuse, so I know that's sine. So I'm going to take sine of the angle measure, 63, is equal to the opposite, which we don't know, over the hypotenuse, which is 12.9. And then again, you can put it over 1. I can calculate sine of 63 in my calculator. It's 0.89. And then I can cross multiply. So we get x equals 0.89 times 12.9, 11.481. X is 11.481, so QR is 11.481. In this next one, I'm looking for FD, and I was provided this angle, and I have its adjacent side. So I have my adjacent, my hypotenuse, and the angle F. So that's going to be adjacent and hypotenuse. If I go through SOHCAHTOA, adjacent hypotenuse is right here. So it's going to be cosine of the angle is equal to adjacent, over hypotenuse. So 20 over x. Well, cosine 39 is 0.78 if we round correctly, is equal to 20 over x. I can put that over 1 and I can cross multiply. So I get 20 equals 0.78x. Divide both sides by 0.78. I get 25.64, which means that FD equals 25.64. The video would be too long, so I'll do this one in class for you.